These are the parts we need to make our joint system. They can of course be made in a lot of different sizes, but the technique is basically the same. The joints work because we create tension with the help of flexible filament. We'll talk more about that later in the video. Making a cup is pretty straightforward. I use a 8mm metal rod and put it in a screwdriver. Now filament doesn't stick to metal, so we apply a little glue to the rod. You don't need to apply a lot, just a little on the top part. Then the filament will adhere to itself. Keep your screwdriver at a low speed and start extruding from your 3D pen. Like so. Just keep going down until you get the length you need. Remove the rod from the screwdriver, and then we simply add the bottom part of the cup. I'll be using different methods to make the flexible filament parts in the video. This is the epoxy putty method. We need a container for the putty. Here I'm using a red bottle cap. Mix the putty well, then push it into the container. Make sure you fill it all so you don't have any voids in there. Then push the same rod we used to make the cup into the putty. And then you wait until it's cured. To make the ball joint holder, you need a ball tool, a container like the one we just made, some flexible filament. I'm using a filament with a shore hardness of 60D and a 3D pen on ABS setting. Fill the container with filament up to the top. Then press the ball tool as center as you can manage into the filament. The filament should cover almost all of the ball, as you can see. This filament cools down pretty fast, so when it's cooled down, remove the filament from the container. And you might have to trim it down a bit since it flows over the edge. So now the flexible part fits snugly inside the cup. The key to making a tight ball joint is to make the ball ever so slightly larger than the ball holder. So here I have glued small 3mm pins to beads with a slightly larger diameter than the ball tool we used to make the ball holder part. I glue these to a flat surface using some super glue. Then we put a box around them wall them in, and use hot glue to prevent the silicone from leaking out when we start pouring. Mix your silicone as prescribed, tap it plenty to remove bubbles, and pour into the mold. Pouring in a thin stream removes bubbles as well. You want to use a fairly firm silicone, since we'll be injecting into the mold with our 3D pen. A softer silicone would deform when injected with filament, so you would end up with a larger ball than you want. Now this could be remedied by putting the injected mold into an oven at proper heat setting, and as the filament softens, the silicone would be able to regain its original shape and push the extra filament out. But this process would take a lot longer, since you would also need to wait for the silicone to cool down enough to remove your parts. When the silicone is cured, remove the box and the parts. When injecting the filament, you want to use a higher temperature than used when doodling and building with the pen. So I use ABS heat setting on PLA filament. With the pen on high speed setting, start injecting into the mold. As the mold starts to fill up, I push a little with the pen a few times to ensure that the filament fills the mold properly. To make a flexible filament pin holder, we need a metal pin. Here I'm using an aluminium rivet with a diameter of 3 mm attached to a screwdriver. You can of course use something else like the smooth part of a wood screw. I'm using aluminium because it's softer and much easier to shape. So using a metal file, I start with removing the head of the rivet. Then I form a pointy tip by filing at an angle. This will make it easier to push into the filament. Then I score the pin, making a groove by the tip. Now here I'm making the length of the head a bit short, it should be a little bit longer. I also file off a very small amount of the diameter of the pin. The pin holder is made much in the same way as the ball joint holder. Flexible filament injected into a container. In this case I'm using a 5 mm drill guide. Keep the pin close at hand, since you need to quickly push the pin into the filament, as center and straight as you can. This part goes into another cup of proper size. So you make a 5 mm cup instead of the 8 mm cup we made for the ball holder. Remove the pin, and if unsure, check the filament that is shaped itself into the groove on the pin. So you'll have like a small ring inside of the pin holder. I'm going to zoom in soon, and I'll show you inside the pin holder so you can see the small ring. Right there. The filament pin is also made in a silicone mold. It's simply a smooth 3D 3 mm pin. No groove or head part. These are shaped later. So same as before, inject filament into the mold. You don't need to add much pressure here since it's just a smooth pin shape. And for some reason I'm giving you a bonus ball joint part to view. So wait until it's cooled and then remove. Now we make the groove in the pin with cutters. I'm just working my way around the pin close to the tip of it and gently squeezing a groove into the pin and thereby shaping the head. After that, you just test fit it in the pin holder you made, so you could feel it snap into place. To make the disc part, I use a 3mm thick metal plate with a round hole in it. Since we need to attach the disc to another part later, without compromising the disc shape, we need to modify this a little. So I file a little notch on one side of the disc, outwards. Then I take another metal plate and drill a small hole that can accommodate the tip of the 3D pen. So we create a low-tech mold by sealing the shape with a third plate. I'm using a plexiglass piece and a non-stick surface here so we can see what's happening inside of the mold. So high speed, high temperature, and start injecting. Make sure it fills up completely, especially the little notch we made there on top. I'm pressing down a little bit and remove the bottom plate. So now we need to find the center of the disc so we can drill a hole for the pin. Using an engraving caliper, I guesstimate the radius of the disc, then I place one point on the edge of the disc and scratch the surface with the other point. Like this. I repeat the process at multiple places and the center will eventually be marked out. So here you can see clearly, there's a little ring there, that's the center. So we take a pointy tool and press into the center, creating a small notch there. Small indentation. Now we can remove the disc and cut off the part that created by the injection hole using flush cutters. So I place a 1mm drill in the center notch and drill straight through the disc. It's very important that it's straight through, so 90 degrees all angles all around. Then I follow up with a drill with the same diameter as the pins I will be using later. In this case it's a 2mm drill. A little cleanup might be necessary to remove the burr created by the drilling. To create tension in the disc joint, we need to create a bracket which will hold the disc in place. It will also house a piece of flexible filament that pushes up against the disc. The bracket is created with a length of flat filament. I'm smoothing out the end of the piece. It makes it easier to drill through later. So I place the filament on the same flat metal plate we used to make the disc. Like this. Heat the filament with the tip all across the width until it becomes soft. You'll notice that it starts wobbling. Then bend it over the rim of the plate. And we repeat the process over to the other side to finish the bracket shape. And we just pull out the bracket and cut to equal length. To be able to create housing for the flexible filament part, we need the bracket to stick out a little, creating a void right next to the disc. We need the flexible filament part to be contained, so we create a little box for it. To make it easier to create the box, I'm using a small piece of silicone. So the hot filament doesn't flow into the box we want to create. You don't have to use silicone, you can use something else. It's just a way to stop the filament from going inside to in the box. Then we do the same thing on the other side. Cleaning stuff up as we go along. And we do a little test fitting and noting where we need to drill the hole for the pin. So we drill a hole near the end of the brackets. Check so you drill straight through. same technique as I did before. I use a 1mm drill first and follow up with the 2mm drill. And as before, a little cleanup might be necessary to remove the burr left by the drilling. So here I have removed one of the walls of the flexible filament housing to show you what happens inside the joint. To show this clearly, I'm using a piece of silicone. This green part will be replaced with the same flexible filament we've been using so far. So the idea is to have the flexible filament stick out of its housing a little bit. Then we push the disc against it and insert the pin. Now the disc is under constant pressure and therefore can hold in the position we want it in. It's very important that the pieces we want to stick together when we create our parts are firmly attached to each other, or they will break when we move our figure's limbs and they come under tension. To achieve this, both parts need to be melted a bit and then melded together to form one solid piece. This is trickier than it might appear, since we do not want to push the molten parts together as much as we want it to flow together. So it's a little bit of both to get a good result. So you need a heat source. It can be the tip of your 3D pen, an adjustable heat gun with a nozzle adapter to make the hot air stream smaller, or a wood burner tool. The wood burner tool is way too hot to melt plastic filament properly, so I use a dimmer to be able to adjust the heat. You'll see an example of that in a minute. When we attach more filament to each other, it's got lots of connection points, so you don't have to melt everything and make it flow together. Some filing might be needed. So here's the wood burner tool and the dimmer. So hook it up, and then you can control how much heat is created at the tip. We don't want to burn the plastic. Burning makes the plastic brittle, and it also can create air bubbles inside, making the melding weak. practice melding pieces together. Make joints, put ball joints on a disc, put pins on a disc, put whatever on a disc, make crazy stuff. You need to practice. Okay, so let's go through the figure part by part. The head is a cup with a ball holder inside of it. The neck is a so-called barbell joint. The upper body is made from two large ball holder cups, one for the neck and one for the lower body, with two pin holder cups attached on the sides for the arms. Now when attaching cups together like this, we need to make sure that the heat from the filament doesn't warp the cups. So we put the cups on the metal rods we used when making them, and then use the 3D pen to attach the parts together. Then we have another barbell joint that of course goes into a ball holder. It's a bit shorter, doesn't need to be as long as the neck. The lower body is made from a cup and then some extension down to two ball joints sticking out on the sides like so. The shoulder joint is made with a pin holder and a pinned disc. After that, we make a pinned bracket. The upper arm is made of two pin cups facing away from each other and then attached to each other. So a pin holder, and this will form the biceps swivel. At the elbow there's a pinned disc. Lower arm starts with a bracket, which is connected to a pin holder cup by the wrist. There we go, pin holder and a teeny tiny pin disc to attach the hand to. Now to make a nice hip joint, we need to establish how much to angle the ball holder and cup to create the lowest point the leg can bend to inwards. Move the cup as far down as you can and then note how you need to connect the pin. So straight leg, a little wider stance. You choose what default you want. There we go. A hip joint with a ball holder, cup, and it's pinned. The upper leg starts with the pin holder, then it has an extension down to a bracket part. I usually just made tubing, just like we make the cups, but a bit longer to make the extension parts. And here we're going to use a double disc knee joint, so it's a double hinge. And lower leg starts with a bracket, then an extension piece to a pin holder by the ankle. The ankle joint is a pinned bracket, like that. Then we have a pinned disc. So we angle the foot, pin the disc like this to connect the foot. And the foot is a pin holder cup attached to like a platform. Basically, you could say it's a sole of a shoe or a foot. Pin holder goes in, and then you just connect it to the pinned disc, like so. Now you have an ankle pivot, which you also can rotate. The other side is of course made exactly the same way. Like so. Done. Sometimes we want to prevent the disc joints from rotating the wrong way, and this is the solution for that. See, I made a little small blob of filament there, and then there's an attachment to the upper leg that almost touches the disc. Right there. So when you bend it forward, it stops. Since we'll be using polymer clay to make the figure, sometimes we don't want it to be able to bend upwards because we have clay there, and clay would break after a while. So we want to stop it from bending the wrong way. next episode, we're going to start sculpting with polymer clay on top of the articulated skeleton we made. I'm going to talk about the do's and don'ts and stuff to think about in general. Thanks for watching. I'll see you next time.